Hi everyone, welcome to sprint 15 of Dogen. As usual, it was a very busy sprint with a lot of work being carried out. Sadly, a lot of the work was not user-facing, mainly because it's to do with in-depth analysis of variability management and sort of more technical work. However, I thought I'd take the opportunity to demonstrate the couple of changes that we had by showing some of the less common or less used features of Dogen, and may also be useful. I'll also talk a little bit about a way to do REPLs in C++ using cling, which integrates quite nicely, and it was the main reason why we added static libraries to this release, or shared libraries, should I say. So without further ado, so as I said, there's only two changes to this release that are user-facing. The first one is that the CMake files are now generating the correct mode line. Before we didn't really use the right variables in Emacs, which meant that the tab width was not correct. In addition, we stopped hard-coding the type of the library, static or shared, on the CMake file directly. The main reason why is to enable us to generate shared libraries, so we can use them in cling. So I'm just going to do a quick demonstration of this. So I'm just going to go here to Emacs. So most users are already familiar with dia as an input to Dogen, and that's kind of how I use it most of the time. But there's a second front end, which is JSON, and at present it should have most, if not all, of the functionality that we have in dia as well. So if I just quickly go here to our little demo project that we use for every sprint, you can see that I generated here an hello world JSON. And this hello world JSON is equivalent to the dia model that you saw a second ago. Now we still have a couple of bugs in JSON. So for instance, we have duplicate keys on an object, which is not valid according to the JSON standard, and there's a fix that are going to come in at some point for this. So when we convert the dia model to a JSON model, the model still needs a little bit of manual massaging, but in the future that's not going to be the case. So I'm just going to use this model, and what I'll do is I'm going to jump over to my shell, and I'm just going to generate the JSON model and then jump over to Git. And what you'll see here in Git is after generating this, sorry, one thing I should have mentioned is I just return to my Git screen. Yes, so as I was saying, one thing I forgot to mention is that the version of Dogen that we are using, which is just here, is up to date. Let's just make sure. And as you can see, it's version 15, which is previous sprint that we just finished. So as I was about to say, this new release of Dogen now fixes the CMake tab width variable. As you can see there, it's now generating the correct variable name. But in addition, as you can see here, we're hard-coding static as a type of the library. That no longer happens with the new release. We just remove static. We've also added some blurb for the installation both of static and shared libraries. So the good thing about doing this is that CMake now will take the input from the user and determine what's the right thing to do. So if I now compile, well, actually I just did a build for this, so you're not going to see very much at the moment. But what I'll do is I'll hop onto Git again. I'm going to remove the changes from here, and then I'm going to go back to compilation. So this is the compilation as it was from the previous sprint. It's just going to generate a static library, and you can see here there's the static library is being generated there. That is even though I'm asking CMake to generate shared libraries. The reason why is because we hard-coded in the CMake target. However, if I now go back to my shell and if I generate again, I'm just going to move up a little so you can see the command that I'm running, and return to Git, and as you can see here, the changes are back. And then if I now go back to my compilation, what you should now see is it recompiles the model, and it will this time generate a shared library rather than a static library, as you can see here. So why do we go to all that trouble? Well, the main reason we got to all that trouble is because we decided to experiment with a tool called Cling. And Cling's got some basic Emacs support. Cling is in effect a REPL for C++, for those familiar with Lisp. And what it allows you to do is it allows you to sort of test C++ code as you go along. So what I'll do is I'm going to load into my Cling session I got here in Emacs my library for this model, and I'm also going to add all the include files for this model. Sadly, it's that the input here is not very pretty, but you can get the gist of what's going on inside the Cling. And then I'm just going to start off with, I'm just going to add all these includes, which are a utility for the model. So I'm going to, as you can see, every time I select a region here, I can then just say Ctrl+CR in Emacs, and it will just copy the region over to my Cling buffer. So first, I'm going to just define a test data generator and create an instance of the one property type, which, as you can see in Dia, is just a very simple object with property and property 2, funnily enough, no longer a one property class. And what I'll do is I'm going to tell Cling to just generate an instance and then dump that into stout. And you can see that happening here, and that's done. And then the dumping using our IO streams results in this bit of JSON here. And the good thing about this, of course, is that I can now just JQ it, and then Emacs will show me the JSON nicely indented and highlighted and so forth. The other good thing about this approach as well is that I have full Clang D integration, so when I'm writing code, I can make sure this code is perfectly valid because I can see all the errors that are going to come through. And Cling is very useful because I can define functions in Cling as well. Like I just defined this function here. It will automatically do the raw input for me. So now if I just call func, it executes the function, as you can see here. And what I'll do is, as you can see again, and of course then I could do things such as, well, I'm going to use the instance that, apologies, I'm going to use the instance of the object that we just defined a second ago and say property equal to tests, for instance. And then if I just do again stout op stood and line, hopefully what you'll see, it's not very obvious with the JSON this way, but as you can see here in the JSON, we now have test as the value of the JSON. And so you can see Cling is very, very useful, and you can imagine you could do much more complicated things than this just simple example. For our particular purposes, we are trying to use Cling in the development of Dogen so that I can work on a transform and then execute the transform within Cling and see what the transform does, which is extremely useful. This sprint, there isn't very much more to talk about, but the next sprint, the target of the sprint is going to be exactly what it was in the previous sprint, which is to add support for profiles at the meta model level, which like I mentioned before, would allow you to then do things like define hashable and serializable and things like that. And this could be really useful for end users. So hopefully that's what's going to happen in the next sprint. That's all for this sprint. Thanks very much for watching.